Alright, logic fans, welcome to our second video on universal generalization, and we're just going to keep charging through some examples here. So I want to draw our attention to this one, which forces us to close in on some key aspects of universal instantiation and universal generalization. So here's your premise. I've got you started here. See if you can't go ahead and finish this one. Intuitively, it is a valid argument, right? The order in which the quantifiers are stated in a sentence like this shouldn't matter, and it doesn't. So let's go ahead and prove that. Pause now and give it a shot. Okay, hopefully you were able to figure it out. I just want to draw our attention to a few aspects of this, and I've broken it up into groups here. This group of sentences just sort of universally instantiates both the quantifiers off, and then this reattaches them. So let's go through this nice and slowly because the details here are actually really important. You cannot just sort of detach the y. Alright, so if this y here, you have to detach the x first. This is a universally quantified sentence. This is the main connective or universal quantifier on it, okay? So if you apply universal instantiation, you're going to detach this one, and you're going to detach anything having to do with an x. In this case, there's just this x here, so it becomes the u, and you're left with a universally quantified sentence with the y on it. You then detach it, and while you are free to universal instantiate down to u again, and it would be u, that would create a problem because when you universally generalize, okay, if this was just another u here, you would have to universally generalize, to example, for all x, fx, and gx, which is true and fine and fair and a perfectly sound inference, but it's not what you're trying to build, right? You need a separate one. You need one left over here because universal generalization requires us to place every occurrence. So if you put another u here, you'd have to replace it, and there would be nothing left to universally quantify on to get a second quantifier. So we go to a different one, u sub 1, right? And we universally generalize that, and we have to go to the x first, because if we went to the y first, the y would be in this position, and we want the y out here. So you have to build in the correct order, because we're going to universally generalize this sentence and get this. Then we're going to universally generalize this sentence and get this. Okay, it's a rule of inference, not replacement, right? So if you put a y here, the y is going to be here, and the x or the z is going to be here. But we want, because that's what the problem requires, the x on the inside, we universally generalize it first, and we want it on this one, so we put it on that one, and we leave this guy alone. Then we universally generalize this guy, and putting the y on, and that yields the result. So all of these nice little nuances are important. I also want to draw our attention, okay, suppose you were stuck and you didn't know how to proceed. Well, one strategy you can use is you can reverse engineer the conclusion, the thing you're trying to get to. So if we just picture on scratch paper the conclusion, right, it would look like this, and then ask yourself, what would that look like devoid of all quantifiers? Well, we could universally instantiate down, and you'd get something like this. Then we'd universally instantiate down again, and you'd get something like this, right? And it's like, okay, so I'm trying to build something like this, so I'm going to need a u1 and a u, right? And so that tells you what you're trying to build from your premise, and notice we exactly built something like that, and no, it won't matter if you went to u1 first or u. Okay, let's look at another. So by way of illustrating some of the complexities involved here, we have a interesting situation in this case. So let's look at this for a second. Now, this looks like a syntactic deduction, but it's not. It makes an important mistake, and I want to draw it out to you visually so you can really see it. And it's based on what we were just discussing with the last example. So this guy starts with a premise, right? And he concludes something that you can absolutely conclude, all right? And that's totally fine. The problem is that you can't get to it this way, all right? Like we did in the last one, we did it correctly. In this case, the person strips off all the universal quantifiers from the premise, and that's fine. And then they build with the y first, right? And then they put the x in. The x must go to the left, okay? This is absolutely important for other kinds of sentences. It really matters a lot. So this deduction goes wrong here, okay? And what it violates is that universal generalization is in fact a rule of inference and not replacement. You can't go inside here, inside this thing, and start screwing around. You have to apply it to the whole thing as a fixed construct, okay? So I'd like to close by looking at a final case that involves an existential quantifier in it and kind of how to handle that. So here we have one premise and a conclusion, and it absolutely does follow. It is syntactically valid. You have to prove it by producing a syntactic deduction. So pause now and see if you can't solve this one. Okay, hopefully you were able to get it, but it's not too bad. All you're doing essentially is changing the quantifier from being in terms of x, the universal quantifier, from being in terms of x to being in terms of z. So you strip it off, and then you tack it back on. And in order to tack it back on, make sure you have the universal pseudonym there, not, an A or a B or a C or something like that. Okay, you cannot universally generalize from those. And that's all there is to it. The fact that there's an existential inside here doesn't matter. Now, if the existential is like here and then there's a universal inside, you cannot, strip that off or anything. You have to get rid of the existential one first, because that would be an existentially quantified sentence. And we're going to talk about how to strip on and how to detach and reattach existential quantifiers in the following videos, 6.4 and 6.5. So be sure you're practicing all the practice problems in the text to make sure you're internalizing all of these features of our new rules, and we'll catch you on the next video, Logic fans.